everyone. Today, we are going to discuss some commonly asked data structure interview questions. First question is, what is data structure? A data structure is a way of organizing data so that data can be used efficiently. Different kinds of data structures are suited to different kinds of applications, and some are highly specialized for specific tasks. Like B trees are particularly well suited for the implementation of databases, whilst computer implementation usually use hash tables to look up identifiers. So what we got that data structure is the way of organizing the data. Like in our day-to-day life, used to take the help of different containers to keep different type of things like a glass for water, a kind of pot to means plant a tree or means the flower tea, like that. That particular pot, that particular glass, those containers, these are kind of data structure because the way we organize the data is nothing but the data structure. And due to the different types of requirements or tasks, we need different types of data structure. As here we have given the example of BT for implementation of database, and in computer implementation like we use hash tables. Okay, the next question is, what are linear and non-linear data structures? Linear, so if the elements form a sequence or a linear list, then that data structure, that way of organizing that data is known as linear data structure. Means in case of linear data structure, elements form a sequence. And by the term sequence, we mean what? One after another, right? Or a kind of linear list. The data structures like array, linked list, stack, queue, this belong to linear data structure. Then what is non-linear data structure? This is a data structure where this sequence is not maintained. Means the one by one, this particular thing is not maintained. Or you can say traversal of the nodes is nonlinear. You can take the example of graph. You can take the example of tree. Obviously, graph, tree, these are kind of nonlinear data structure. You know the difference between the graph and tree. If you know, you can answer to comment. Right. So you got it. What is linear and nonlinear data structure? Let's come to the question number 3. What are the types of data structures? Different types of data structure we have, like list, array, records, trees, tables, different types. Basically divided into linear and non-linear. List, collection of related things linked to the previous and following data items. Arrays, collection of values which are or same, means same type. Then records, collection of fields, each of which contain the data from a single data types. Trees, where we organize the data in a hierarchical framework, right? From where we can means perform the operations like insertion, deletion, modification. Similarly, tables, if we arrange the data in the form of rows and columns, these are the different types, right? Now, linear data structure you usually got it that we arrange in a sequence, and if they are hierarchical way we are organizing, then that becomes a nonlinear. Now, examples you got it that array, stack, strings, queue, linked list, they fall under linear data structures. Now, if someone asks you that what are the application of linear data structure, or you can say data structure as usual, because when we use data structure, first of all, you have to remember that if we organize the data efficiently, then only we can expect that the other operations on that, or that other operations, by the other operation term we mean insertion, deletion, modification, retrieval, those things can be easily done, right? Otherwise, if data structure is not there, that will become a mess. So different type of applications are like there: numerical analysis, operating system, AI, compiler design, DBMS, statistical analysis, simulation. So different means operate different applications are there where we need or we have to mandatorily use data structure for efficient output. Right. Okay. Then next question may be asked, because these are the questions I have picked up, which are frequently asked in the interview. Either it can be an interview for some software developer post, or some suppose if you are going to appear for some assistant professor or this type of related post on computer science, then you may face this type of questions, because these are very basic. Next question is that what is the difference between file structure and storage structure? The difference lies in the memory area access. Storage structure refers to the data structure in the memory of the computer system, whereas file structure represents the storage structure in the auxiliary memory. So got it? Storage structure means the data structure in the memory of the computer system. File structure in the storage structure in the auxiliary memory. Then what are the various operations that can be performed on different types of data structure? Told you already, insertion, deletion, and traversal means visiting one node by another one node, then thereafter another node. So those things are known as traversal. Searching means we try to find a location of a particular data item. Sorting means we are trying to arrange the data item in a specific way, either ascending or descending, right? Then what are the types of searching you use in data structure? This may be a question. First of all, two main types, linear and binary. Linear search involves iterating over a data unit in order to perform the required operation. While binary search is a kind of more efficient, we all know that, because it has the ability to split the data into two chunks and then perform a search operation. That is binary. Divided into two, then search will be performed in both the half. While linear means what? We are performing the operation one by one like that. Means iteration over a data unit. Then next question may be, what is array? Array, you know that. I think it doesn't need any more definition, because similar type of data, same data type, or you can say like similar data type, that type of data we used to store in an index way, then that becomes array. Like usually start from zero, suppose n elements are there, then a02, suppose a is the name of the array, then a02 a n minus 1. Now this question is that what is multi-dimensional array? So obviously if more than one dimension is there, then that becomes a multi-dimension, right? It is an array of arrays or an array with numerous layers. The 2D array means two-dimensional array is the most basic multi-dimensional array. You know, 2D means rows and columns we are using. So that becomes a 2D array example. So can you cite some example of 3D array? If you can, then please use the comment section to put your answer. Then how are the elements of 2D array stored in the memory? Basically, we know about two different way. First, row measure order. Second, column measure order. Row measure order, all of the rows of a 2D array are stored in memory in a contiguous manner. First, the first row of the array is entirely stored in the memory, then followed by the second row of the array, and so on until we reach the final row. That is the row measure order. Okay, got it? First row, then second row, until the last row. Then column measure order. In column measure ordering, all of the columns of the 2D array are stored in memory in the same order. First column of the memory means array is entirely saved in the memory, followed by second row of the array, and so until the last. No, this should be second column. Okay. So first we store the first column, second column, then until we reach the last column. That is the column measure order. So two ways, row measure order and column measure order. We can say one's horizontally, another one is vertically. Okay, let's come to the next question. What is a linked list data structure? Linked list. First of all, remember linked list is a linear data structure. Okay, this is a sequence of data objects where elements are not stored in adjacent memory locations. The elements are linked using a pointer to form a chain. Okay, so in case of linear data, means linked list data structure, we use what? We use pointer. Just a minute. Yeah, got it. So, got it that linked list is what? Is a kind of linear data structure, but remember, elements are not stored in the adjacent memory location because here we are using the pointers. Okay, these pointers to form a chain. Each element is a separate object called node. Each node has two items, data field and a reference to the next node. The entry point in a linked list is called as head, where the list when the list is empty, the head is a null reference and the last node has a reference to null. So basic points you have to remember, every object in a linked list is known as node and each node has two items, data field and a reference field. Data fields contains the data and the reference field contains the address to the next node, right? And the entry point of the linked list is known as head. And if the linked list is empty, obviously head is a null reference because that is the entry point now, pointing to the first node. That is, if the list is empty, then head will have a null reference and the last node has a reference to null. Now, this linked list is a dynamic data structure where the number of nodes is not fixed and the list that has the ability to grow and shrink on demand. This is the advantage. It may grow. Okay, obviously the storage is concerned, means it can grow up to a particular storage limit what you have in your system, but it has the ability to grow, right? Then it also has the ability to cut few nodes, that means to shrink on demand. It is applied in cases like where we deal with an unknown number of objects or we don't know how many items are in the list. We need constant time insertion and deletions, insertion or deletions from the list, as in real-time computing where time predictability is critical. Random access to any element is not needed. The algorithm requires a data structure where object needs to be stored irrespective of their physical address in memory. We need to insert items in the middle of the list as in the priority queue. So these are some cases where we use basically linked list. If the interviewer asks you that, tell us some cases where we apply, where you will prefer linked list. So first of all, when you don't know the number of objects you need. Second of all, you also means what we can say that constant time insertion deletion means if the insertion and deletions we need repeatedly, then we can do it, right? Then we suppose random access to any element is not required, then you can say that if we need to insert items in the middle of the list, then also, so these are the cases where we need linked list. Some implementation of stacks, queues, directory of names, dynamic memory allocation, and performing arithmetic operations on long data. These are also some such cases. Okay, you got it. What is linked list? Now you tell us that how an array is different from linked list. Main thing you got that linked list is dynamic in nature. Dynamic in the sense it can grow and shrink as per the demand is concerned. But the size of array is fixed. Got it? So this is the first difference. Array size is fixed while linked lists are dynamic in size. Then inserting and deleting a new element in an array of element is expensive. Whereas both insertion and deletion can easily be done in linked lists, right? Random access is not allowed in the linked list. Got it? Because you can go through one by one. Don't forget that it is a linear data structure, although The elements are not arranged in a continuous manner, but still is a linear data structure. So random access is not allowed in the case of linked list, right? Extra memory space for a pointer is required with each element of the linked list. So I told you initially that obviously storage is concerned here because you need extra storage to keep those pointers referring to the next node, right? Array have a better cache locality that can make a pretty big difference in performance. So these are the differences. Very important question, difference between array and linked list. Next question. Are linked list considered as linear and non-linear data structure? Obviously, first I told you this is a kind of linear data structure. But sometimes the answer may be like, it may be considered as a linear or non-linear depending on the type of the application they are being used for. Like for access strategies, it is considered as a linear data structure because you cannot directly have a random access, right? But when used for data storage, a kind of non-linear data structure because here we are using the pointer, and pointer may refer to any location, not contiguous. So in that way, you can think is as a non-linear data structure, right? Okay. Next question. What is a doubly linked list? Give some example. Doubly linked list, double-ended linked list. This is a linked list where each node has two links. One that connects to the next node in the sequence, another that connects to the previous node. Means you are here, you have two hands pointing, one hand pointing to the previous node, previous person, and another is the next person. Similarly, in the case of doubly linked list, a node has two links. Every node has two links. First link is pointing to the what? Pointing to the previous node, and the next the other pointer is pointing to the next node in the sequence. So this allows the traversal across the data elements in the both directions. Initially, if it is single linked list, then it can go in a particular one direction. But if it is doubly ended linked list, then it has two pointers. It can move frontward and backward also, right? Examples like music playlist with next and previous navigation buttons, right? Browser cache with back forward visited pages. You can see in the Google Chrome, you can have this means back and forward visited pages option, right? You can move to the first pages you visited, then next pages also possible. So back and forward, right? Then undo and redo functionality on a browser where you can reverse the node to get it to the previous page. So these are examples. Then how do you reference all of the elements in a one-dimensional array? Right. It's very simple. I told you already, if n elements is there, then 0 to n minus 1 are the index. With that index, with that subscript, you can easily refer to any element. Then dynamic data structure, what is that? Name a few. These dynamic data structures are collections of data in a memory that expand and contract, grow or shrink in size as the program runs. This enables the programmers to control exactly how much memory is required. Like example, linked list, right? So another example may be queue, heap, stack. Okay, next, what is stack? What is stack? Obviously, stack is kind of what type of data structure? Is a kind of linear data structure, right? This is a kind of order list in which insertion and deletion can be performed only at one end. Okay, and that is top. Means top you can consider as a pointer pointing to the top element. And the order it follows is known as LIFO. Everybody knows, right? Last in, first out. Okay. So last in, first out means what? The element inserted first in the stack will be the last to will be the last to be deleted from the stack. Means you are arranging the books on your table one above the other. Obviously, the first book you have kept will be the last in that particular stack, right? Stack of those books. So you cannot just pull the first book because if you pull it directly, the other books will fall. So first, the last book you have put, that is the book to be removed first, or to be the pulled first, then one by one, then only last one is the first one you have kept on the table. So that is the last in, first out. Okay, last in, first out order, followed in stack. Now, list the area of application where stack data structures can be used. Expression evaluation, we use this, right? Then backtracking, memory management, functions calling and return. So these are some applications where we use stack data structures. Now, if somebody asks you what are the operations that you can perform on a stack, push operation means insertion, pop operations, deletion, pick operations, or pick operations means what? We are just means concentrating one particular element. Now, write the stack overflow condition. Stack overflow means, suppose size is n, you try to insert element on n plus 1 beyond the size limit. That is the stack overflow, right? So overflow occurs when top is equal to max size minus 1. Don't forget, from the array definition, index array, if is of size n, then its index comes from 0 to n minus 1. Similarly, if the max size is the total number of elements in that stack, so obviously maximum size will be max size minus 1 if we are considering it from 0. So if top is at max size minus 1, so it is the top element, it already occupied all the space. So in that case, stack overflow will occur if we are going to perform insertion operation. Okay, so push for insertion, pop for deletion. Now write the steps involved in the insertion and deletion of an element in the stack. First, you have to see, in case of insertion operation, you have to check whether it is the overflow condition being set, checked or not properly. You have to go through. Right. If overflow is there, you cannot go for insertion. If underflow is there, you cannot go for deletion. Underflow means no element is there, still you are trying to delete the element. So push operation, increment the variable top so that it can refer to the next memory allocation. Suppose if it is at fifth location, if the array size is 8, it is okay. Then you can increment top size to 6, top plus 1. Then copy the item to the array index value equal to the top. Then these steps to be completed until we reach the condition of stack overflow. Means if stack overflow is there, we have to stop. We cannot perform the insertion. Then in case of deletion, we need to decrement the value of top until we reach the topmost element. Then what is postfix expression? See, postfix expression means what? When in an expression, operators follow the operations. Operators follow the operands. That is the postfix expression. What is the benefit of it? The main benefit of this form is that there is no need to group sub-expressions in parentheses. You got it? We don't need parentheses here. Like this plus B. This is the expression. Now, the postfix expression of this, postfix notation of this, or an expression of this A plus B will be what? Operators follow the operands. So AB plus, this is the operator, plus operands are AB. Okay. Okay, write the postfix form of A plus B cross C minus D. Very good. It is very easy because if parenthesis is there, priority is there. So we have to evaluate that first. So A plus B, AB plus C minus D, CD minus. This multiplications come front of it. So this one. Any confusion, you can ask. Which notation are used in evaluation of arithmetic expressions using prefix and postfix form? Polish and reverse Polish notation we use. Then in prefix, postfix, no need extra definition like this. X plus Y, it is infix. X plus Y is the infix because that particular operator in between them. Now, XY plus is the postfix and plus XY is the prefix. Similarly, you can go through this example here. This is the infix operations, right? Postfix means what will be the postfix? In this case, BC plus, right? Then who has the highest priority? The star, A, B, C plus star, then D, this. This is a prefix. Then prefix is also known as Polish notation. Like this, in this case, what? Plus will come front of it, plus a star is come in front of it, star. Okay, this division is coming. So this is prefix of notation, also known as Polish notation. Postfix means reverse Polish. Infix is the one where operator means that is in between that particular operands. Okay, I don't think that any doubt happens to occur here. If there, you can ask me. Now, what is queue? How it is different from the stack? How it is implemented? Remember, last in, first out, that is stack. First in, first out is the queue. Queue is everywhere. Means suppose in a bank, you are waiting for your turn in a particular counter, right? On a particular, in front of a particular counter. Obviously, if you are at the first position of the line, you are the one who will get the service first, right? So first, who comes first will be given the service first. Similarly, first in, first out. That is the pattern followed in the case of queue. Queue is again a linear data structure. And mainly the basic operations are here like NQ, DQ, front and rear. So NQ, insertion, DQ, deletion, front and rear are the two ends, right? Front and rear are the two ends where the operations can be performed. Now, difference between stack and queues. In a stack, we remove the item that is most recently added, right? While in case of queue, we remove the item the least recently added. Both queues and stacks are implemented using arrays and linked lists. Okay. Linked list, I don't think any doubt occur. So it is clear. Now, which data structure we use in base first search and breadth first search and depth first search? In case of breadth first search, we use queue. Remember, in case of depth first search, we use stack. Okay. Now, can doubly linked list be implemented using a single pointer variable in every node? A doubly linked list can be implemented using a single pointer. Okay. So this is again an important question, whether we can use a single pointer to implement a doubly linked list. So a doubly linked list can be implemented using a single pointer. Now, how to implement a stack using queue? A stack can be implemented using two queues. Okay, so if we are going to implement the stack using queue, then we need two queues. Let stack to be implemented as queues are Q1 and Q2. Stack can be implemented into it by making push operation costly, by making pause operation pop operation. Okay, so basically you remember that to implement a stack using a queue, we need two queues. Similarly, a queue can be implemented using two stack. Then how to check if you have given binary trees binary search tree or not. So if in order traversal of a binary tree is sorted, then that is a binary tree, which is binary search tree or BST. Means if in order traversal done, then whatever the output we got, they are sorted, then that is a example of binary search tree, BST. Okay. The idea is to simply do the in order traversal while traversing, keep track of previous key values. If current key value is greater, then continue, else return false. So you just remember, in case of binary search tree, BST, what will happen? In order traversal will give you a sorted element. In order sorted means traversal will give you the elements in a sorted way. Now, what is algorithm? It's a very basic question, but important. Algorithm is a step-by-step method of solving a problem or manipulating the data. It defines a set of instruction to be executed in a certain order to get the desired output. So algorithm, in short, I want to give you the answer. Algorithm are the way of solving a problem. But while doing so, algorithm actually gives us the steps in sequence which has to follow to come to the final solution. But those number of steps will be finite in nature, right? That is an algorithm. So that's why we are calling it as a step-by-step method of solving a particular problem or manipulating a particular problem. Now, why we need an algorithm? Why we do need to why do we need to analyze an algorithm? First of all, because to solve a particular problem, we may have different methods. We may have different approaches to solve that particular problem. One approach is easy, another may be difficult. One approach is consuming more memory, another is less, like that. So we have to analyze them in terms of time and space requirement. So that's why we have to make an analysis, right? And that time complexity of an algorithm quantifies the amount of time taken for an algorithm to run as a function of the length of the input. Space complexity quantifies the amount of space or memory taken by the algorithm to run as a function of the length of the input. So got it? So time complexity, space complexity, we have to measure. Then only we come to know that whether the algorithm we have chosen is a good one or not, right? What are the advantages of heap over stack? Heap is a flexible because memory space can be dynamically allocated and deallocated as needed in case of heap, which is not possible in the case of stack, right? Now, heap memory used to store objects in Java, whereas stack memory used to store local variables and function calls. Objects created in the heap are visible to all threads, while variables stored in the stacks only visible to the owner as a private memory. When using recursion, the size of the heap memory is more, whereas it quickly fills up stack memory. Okay, so these are the advantages. First of all, heap is dynamic in nature. Second, from the case of what recursion also, heap the size of the heap memory is more. Okay, while in case of stack, it easily fills up because size is not more, right? Size is less. So these are the advantages of heap over stack. Use as one word answer. Heap is more flexible or dynamic than stack. Which sorting algorithm is considered as the first stage? A single sorting algorithm cannot be considered as best because each algorithm is designed for a particular data structure and data set. Easily, I have to say that to a different data set, we may need different types of sorting algorithm. Got it? So one particular sorting algorithm may not fit suitable for all types of data or all types of data structure. Like, however, quicksort algorithm is generally considered as the fastest because it has the best performance for most input, right? It is a default one, you can say, if we want to consider a faster one. But still, we have to say that it totally depends on the data set, totally depends on the particular data structure we are using, that which sorting algorithm will perform better in that case. Okay, now it has said that quicksort algorithm is generally considered good because it has some advantages over over the other sorting algorithms. What are they? Cache efficient, it linearly scans and linearly partitions the input. This means we can make the most of the cache load. Can skip some swaps. You know, swapping happens in case of sorting algorithms. Any sorting algorithm you consider, right? Bubble sort, merge sort, quick sort. But in case of quick sort, we have the option for skipping some swaps. A quick sort is slightly sensitive to input, that is right order, in the right order, so it can skip some swaps. Efficient even in the worst case inputs, such as the order is generally random. Easy adoption to already or mostly sorted input, it when speed takes priority over stability. So these are the cases where it has some specific kind of advantages. Then what is merge sort? How does it work? Merge sort is a divide and conquer algorithm. Divide, sort, then divide, sort, then then merge them, right? So merge sort is divide and conquer algorithm. It works by merging and sorting adjacent data to create bigger sorted lists, which are then merged recursively to form even bigger sorted lists until you have a single sorted list. Got it? Divide the whole data set into, say, first two parts, then two parts, then each part to be sorted, merge with the respect another one, then merge with the left one, like that. Short merge, short merge. In that way, we will finally have single sorted list. That is how merge sort works. Got it? How does the selection sort work? This is one of the most frequently asked data data structure question, right? How it works, how selection sort works. It first scans all the items and try to find the smallest one. Okay, then switch over the position at the first item. Repeat the selection sort on the remaining n minus 1 item. We always iterate I from 0 to n minus 1 and then swap with the smallest element. Always I. Times complexity in case of base case, big O of n square. Worst case also, then space complexity big O of 1. So you got in how selection sort works. Let me explain you in a brief, simple way. You have, say, n elements. Out of those n elements, you scan all the items and then find the smallest one and you put that item in the first position, right? We have been left with how many elements then? N minus 1 element. Then try to find a smallest one in that n minus 1 elements and keep in the second position. That means in the first position of those n minus 1 element. Remaining n minus 1, n minus 2. So in that way, we will ultimately got all the elements sorted. So selection sort works in this way. Complexity, you remember, big O of n square. Space complexity, big O of 1. What are these big O? We know about that, right? These are asymptotic notation. Okay? So asymptotic analysis, question may ask that, next question may be asked that, what do you understand by asymptotic analysis of an algorithm? Asymptotic analysis is the technique of determining an algorithm's running time in mathematical units to determine the program's limits, known as runtime performance. The purpose is to identify the best case, means where the algorithm is performing means best, okay, worst case and average case for completing a particular activity. While not a deep learning training technique, asymptotic analysis is an essential diagnostic tool for programmers to analyze an algorithm's efficiency rather than its correctness. Efficiency we try to find out with the help of asymptotic analysis. Notations are like big O, theta, omega, right? Big O, large theta, and big omega, like that. Okay, so the asymptotic notation, it actually represents the algorithm's running time, means how long an algorithm takes with a given input. Okay, the three notations, actually their small versions are also there. Now we are using big O, large, big theta, big omega. Okay, when the running time is the same in all circumstances, then we use big. Okay, big O. And worst case running time, big for the base case running time, like that. Okay. Then next question is that what are some examples of divide and conquer? Quicksort is an algorithm. Parse, in this case, we try to select a pivot element, then rearrange the element so that all the items less than the pivot chosen element go to the left side of the pivot. All the elements more significant goes to the right side. So it's also an example of divide and conquer, right? Merge sort, I already told you. This algorithm divides the array into two halves, then sort them recursively, and then combines those two sorted halves. The goal of the points that are closest together is to identify the nearest pair of the points in an XY plane collection of points. Okay. Now, this is the big O n square time required. So you got it, the two famous example of sorting algorithm which follow divide and conquer are quick sort and merge sort. Graph data structure, nonlinear data structure, right? Here we have vertices, nor node connected by edges or arcs. And these edges may be either directed or undirected. Examples, what are the applications of graph data structure? Like, transport grids, where stations are represented as vertices, routes as edges of the graphs. Utility graphs of power or water, social networks graphs, neural networks graphs. So these are some examples of graph data structure. Even in your Facebook also, we use what? Graph data structure. Different types of tree are there. Tree, I know na, means we know na tree. What is the tree? This is again a nonlinear data structure. But how it differs from the graph, because here cycle is actually means is avoided, right? So a tree is referred to as generality, or when if it is hierarchy is not constrained. In generality, each node can have an endless number of offspring. All other trees are subsets of the tree. Similarly, binary tree is a type of tree where each parent has at least two offsprings. The children are referred to as left and right. Right? Got it? When specific limitation and features are given, then that binary tree becomes either a BL tree, binary search tree, RBT, like that. Then binary search tree is a binary tree expression that includes numerous optional constraints, where left side value is less than or equal to the parent, while right side value is greater than or equal to the parent. Okay, AVL is a self-balancing binary tree. The term AVL is given in the honor of the inventors. Who are the inventors? Adelson, Valchi, and Landis. So this was the first tree to achieve the dynamic equilibrium. Each node in the AVL tree is assigned a balancing factor based on whether the tree is balanced or not. The node kits have a maximum height of 1 AVL fine. Then red and black tree are another type of auto-balancing tree. Red black terms are used from the qualities of the red black tree, which has either red or black painted on each node. It helps to keep the forest in balance. Even though this tree is not perfectly balanced, the searching process takes just big of log n time. Similarly, an array tree. So this is a tree where n is the maximum number of children. A binary tree is a 2-year tree, right? Similarly, since each binary has not more than 2 offspring. A full n array is the one where the children of each node are either 0 or n. Got it? Okay. Next is binary. You just got it that this is a data structure, tree data structure specifically, where 2 offspring are there for each node, left and right, right? And data will be there. Each node, in case of each node, we have data and a pointing device to the left key and point an arrow to the right or correct side. Then what are the differences between B tree and B plus T? B tree and B plus T. Data stored in the leaf node as well as internal nodes also in case of BT. Okay, but if it is stored only in the leaf nodes, then that becomes B plus T. So in case of B tree, we store the data both in the leaf node as well as the internal node. But in case of B plus T, we store data in leaf nodes only. Searching is a bit slower as data is stored in the internal node as well as leaf nodes, right? Where in case of BT. But in case of B plus tree, searching is faster because we store the data only in the leaf nodes. No redundant search keys are present in case of B tree, but redundant search keys may be present in case of B plus tree. Deletion operation is a bit complex in case of BT, while deletion operation we can easily do because you can directly delete the data from the leaf node in case of B plus T. Leaf nodes cannot be linked together, but remember in case of B plus T, leaf nodes are linked together to form a linked list. So these are the differences. So we can easily say that B plus T is kind of faster one. Faster was in the case of searching some data in that particular list. Now, what are the advantages of a binary search over a linear search? Can you tell me? Very simple. Because in case of linear search, what are the pros? What are the advantages? It's much simpler than the binary search and can work on unordered and ordered list both. Cons or negative point in case of linear search is that it is an inefficient way of searching, only generally used for small lists. Now, if we talk about the advantages of binary search, it is much more efficient and quicker than linear search for large lists of data. Means for large list of data, we prefer binary searching. And it is more efficient. Okay. Why? Because the larger the data set, it gets discard half of the information every steps. But only one point is that data must be already in order. Then only perform binary search. Okay. Now, next ABLT, we just got it. ABLT is a height balanced binary search tree in which height of the left subtree and height of the right subtree differ at most by 1, not more than that. Like this figure 1 shows an example of ABLT, figure 2, not ABLT. Why? This is the left subtree, right? And this is the right subtree. Differ by 1. But this is differ by -2. Okay. So ABL means name of the inventors, Adelson, Valsky, and Landy. Height difference between left and right subtree is at most 1. Okay, so this controls the height of the binary search tree by not letting it get skewed. This is used when working with a large data set with continual pruning through insertion and deletion of data. I hope now ABL is clear to you. Let's come to the next question. What is the difference between null and void? Null, first of all, null is a value, while void is a type, data type identifier. You know, na, void main. What is the return type? Void. So void is a kind of data type, but null is a value. Null indicates an empty value for a variable, nothing, empty value, right? Void indicates a pointer that have no initial size. Now, null means it never existed. Okay, null, nothing. So a value which is nothing, right? But void is there. Void is a data type identifier. So void means it existed, but it is not in effect. So this is the difference between null and void. Null, value, empty value, and never existed. But void means what? Data type identifier existed, but not in effect. Next question may be, what is the meaning of data abstraction? Data abstraction is widely used tool in data structure. The goal is to break down the complex entities into smaller problems and solve each of them separately and finally merge them, right? So that is the data abstraction. This provides users with the advantage of being focused on the operations and not worried about how the data is stored or represented in the memory. We don't need to take care, we don't need to consider those things, that how data is stored. We have to just focus on the operations where we are performing. Okay. Then what is jagged array? Jagged array is an array where elements themselves are arrays and may be of different dimensions and sizes. So if in an array, each element itself is an array, and that may be of also different dimension. That is a jagged array, like this one, array 4. So array 0, 3, right? Array 1, 2. So each of them, see, they are of different dimensional array. So that is an exact array. Then explain the max heap data structure. Heap is a very dynamic one, right? It is a type of heap data structure where the value of the root node is greater than or equal to either of its child. Then that becomes max heap. Then priority queue. In case of priority queue, we usually follow 2 queues, right? This is a abstract data type. Means we need to focus on the operations only. Means suppose queue means what? First, second, third. Suppose you are means driving on you are in a queue while driving, but an ambulance comes, right? Instantly an ambulance comes. You should not say that you have to. You should not say that say to the ambulance that you have to wait on the queue, because ambulance is of urgent priority. It has to reach the hospital first. So you will give the side to that ambulance. Okay. So priority queue means priority is given to the elements, and based on that priority, the operation will be performed. Got it? So this is an abstract data type that resembles a normal queue but has a priority assigned to elements. Elements with higher priority are processed before the elements with a lower priority. A minimum of 2 queues are required, one for data and another to store the priority of each such data element. Okay. Then next question, pointers allocate memory for data storage. True or false? False, because pointer operations such as declaration will not allocate any memory for the storage of the data. But memory is allocated for the variable that the pointer is pointing to. Memory processing begins only when the program begins its execution. Got it? Then what is the meaning of DQ? DQ means double-ended queue. Means elements can be added or removed from any one of the two DENs. So it can be used both as a regular queue or as a stack. It performs better than both linked list and stacks in general. Then next question, what are the data structure that are used in graphs? So now to implement a graph, we actually use two data structures. First one, adjacency matrix, used for sequential data representation, means which node is adjacent to which one. Then adjacency list, used to represent the linked data. Okay, so this is the last question of this class. So in this class, we actually include some of the important interview questions on the area of data structure. But remember, these are not limited. These are the frequently asked ones. There may be questions apart from them also. If you have some such question, then you can, of course, comment, then I will prepare another lecture on that. And still also, I'll try to bring one more lecture on this type of particular interview-based questions. But for today, it's sufficient. Just revise them, go through the video again and again. Then obviously you are not going to forget this question. And these are the basics that are the obvious target of the interviewers. That's all for you. My best wishes. Thank you. Bye-bye.